Hello everyone. In this coding blocks, I'm going to take you through a couple of methods we can use in order to manipulate images based on values from the PLC. Now, this is quite a common request that we get to say, well, actually, if I have maybe a fuel tank or some form of fan that spins, how do we influence the images that we can put on our screen? Influence them in a way that they match fill levels, for example. So I'll take you through a few. With JavaScript, HTML, CSS, there are so many different ways of doing things. These are just a couple. There may be easier ways of doing this. This is just a way I use. And these are going to be live coding as well. So there'll be mistakes. You'll see how I go make my way through this task. Hopefully that adds some extras as we go. Okay, right. First thing I'm going to do, actually, I've got a Twinker HMI project opened up already. I'm just going to add a new project to this because we are going to need a PLC element to this. Twinker XA project, PLC, obviously that sits inside a project. So starting off with a PLC project, and I'm just going to call that something simple, PLC project, so we know. Okay, and then inside PLC, add new item, and we're going to go for a standard PLC project. Empty PLC projects, they're good if you're going to do things like libraries, for example. You don't need any of that, all the rest of the things that come with a standard PLC project. But otherwise, standard PLCs, this is where we're going to go, so I'm just going to go, I'll just call it main for the moment. Okay, so main project, and just inside the POU, I'm just going to make a couple of variables that we can use. So I'll do fill, oops. Let's say it's tank 1 level, and we'll actually do 2 at the same time, so tank 2 level, and these are going to be just integers we'll do for the time being. If we just activate that configuration. There is a way, if you have symbols and you generate a symbol file, you can actually import those into Twinker HMI in the new version. In the older version, so anything from 12, in the older version, version 10, you had to point it at a running Twinker runtime in order for it to find its variables. Yeah, that's a step you don't need to take anymore. You can actually export the symbols. I'll do a second video on that rather than digress too far. Yeah. Do love to digress, but not too far in this one. A restart Twinker HMI into run mode, yes we do. Just wait for this to come up and running. I won't put any values in here because what we'll do is we'll just assign these as we go. Okay, so just going to go live with this one. And we'll hit play. Okay, so we've got 2 integer values, both at 0 at the moment. Okay, let's swap back onto desktop view. So the way we'll go first, let's say, for example, we just wanted to manipulate, I don't know, we've got some form of drawing maybe, but in the center of it, we want it to have maybe a filling square that raises. If that's the case, let's just open up our toolbar. I'm just going to pin the toolbox for the moment. We could say that you can use, in ellipse, we want to have the, sorry, just got to find it here, the rectangle element in here. So a rectangle element, we could therefore say that with a rectangle, we can influence its size, and I don't know, let's say we're looking at a battery charging, for example. Now with this, we'd actually use a rectangle to indicate its charged level, and with that, it means that you could put the picture of the battery underneath. So this is the first style I'm going to go for. So this is just having the ability, it's not really actually image manipulation in any sense at all. We're going to say that we've got an image that lives behind the scenes, and then on the top of that, we're going to put some form of controls that indicate how things are filling. So we're pretending to manipulate the image itself. What we can do, so we have control of, let's just open up the properties now and just pin the properties. Sorry, let's just pin those. Right, okay, so inside our rectangle, we have a fill color, so it's worthwhile setting the fill color for the time being. Let's just put that something so that we can see it. We have the ability to manipulate these, so we can manipulate its height in pixels. We can also manipulate its height in percentage. Now, percentage kind of feels like the right way to do it because you would expect some form of filling tank or battery or anything along those lines to be percentage filled. Percentage is also a great one too, because it decouples you from how full this is. Let's say, for example, you upgrade your battery behind the scenes in your code, and you say, actually, yeah, no, our battery can now cope with, I don't know, 3,000 milliamp hours. Because you're working in percentages on the front here, that you don't have to recode anything. If you use constants and said no, the top level value is 3,500, you have to go in and change that too. So working in percentages for filling levels is always a nice way of doing coding anyway. So if we were going to use percentages, we couldn't use percentages here at the moment because it would go to the full size of the screen. 100% would be 100% of its parent. So a technique that we can use is if we just swap to toolbox and we put in a container, and then we put the container, we put the rectangle inside the container. Now we're at the position where we can say we can go between 0 and 100% because we're doing it based on the container size. So if I just show you this, just driving it myself, and then we'll tie it to the variable and show you that this is probably the quickest first step. This is probably the quickest way. You could have done this using one of our linear the linear graph, but let's stick with this way first because this is a very simple experiment. What we're going to do is because we're going to grow, in this instance, I'm going to say that as we fill up, I'm going to grow from the bottom up. What I'm going to do is attach it to the bottom. So I say that the bottom is 0, the top is nothing. My left and my right, we can say that that is 0 and 0, and what that does, we could have used width as 100%. That would have also been just as valid. But this means that I've now assigned this to the. Actually, let's put it slightly in just so we can see it. Obviously, you could have done 0 and 0. You can see there now we've just got the slight edges of the container that we can see in here. So far so good. Right, and then the height, what we can now say is if this is a percentage and we say 50, as we would expect, it now takes up 50% of the size of the container inside. So had we have drawn this over the top of an image, we could simulate it filling up. So there we go. So what we would do now is let's just, I won't change any of the names on this one here because normally you would go in and just put some sensible identifier names in there rather than just having things just step up as rectangle 1, rectangle 2. You should name them correctly. It makes it much easier to find when you do things like your document outline. So just good practice. But in this instance here, we're going to say that because this part is the thing that is influenced by a variable, I therefore I attach the event to it. It just allows you to keep track of where things are. There's nothing to stop you assigning the event we're going to make to any of the components. It just makes it hard to find. So I'm going to say, because I'm influencing the rectangle via a variable, we can attach it to the rectangle. There's actually an even simpler way of doing this. Let's start with the super simple way. We're just going to say that the height, I'm just going to straight up bind it to that. So there we go. So the height itself, server symbols is going to find these now because the PLC is running. In main, we'll set that as tank 1. There we go, because we've got 0 inside it at the moment. So let's just move this onto live view. And we are going to go behind the scenes and just do a prepared value of 50. And we put this in, and we can now see it's growing. So there we go. We've already ticked this one off. That's complete. The other way that I was going to do it then was assigning an event. So let's say maybe you need to do things where not only are we changing how high it is, but maybe we want to change its color. So we can say, well, actually, when it gets a bit too high, let's start rolling it up through some colors. Then I wouldn't actually assign it. Let's just put this. See, this is why we need our document outline, because we've now assigned it to that variable. The variable is by default 0. We now have a 0 height rectangle in here. So we're going to use our document overview instead. So we can select it, and that allows us to select it here. I'm actually going to remove this off of here for the time being. So let's just reset this, and I'm just going to set my height back to, we'll say 100%, because that allows us to see it nicely. And sorry, let's not go pixels. Let's just do, we'll do 50%, because it allows us to easily select the background and easily select the one that it is. So, okay, so if I was going to do this the other way, what we can do, let's just move this one out the way here. unpin that. I'm going to say that I want an event, and I'm going to have a custom event. And that custom event is going to be bound to tank level 1 changing. So it's only the fact that tank level 1 changed does this now create this event to fire. Inside the event, we're free to do whatever we like. So we could say things along the lines of if, let's have a look, tank level 1 is greater than, we will say 80. Then what we can do is, one of the nice things of also doing it on the control itself is it prompts us to say, well, you are on this selected control. So what we can say is maybe we're going to modify our fill color. So in this instance here, so if it's greater than 80%, we'll set our fill color up into maybe a red. And if it's not, then we'll set ours into, we'll go back for our yellow again. It's already selected our yellow for us. Okay, so that's the first thing. The second thing we want to do is also, again, influence its height. So in order to do that, we're doing that in here. We could have left it in the other property. Excuse me, that would have been completely fine. So, but what we're going to do is just in layout, in height, that's not going to be conditional. We're just going to say that our height is actually data binding in to tank level 1. Okay, let's just make sure that works. Okay, and then if we go into main, prepared value of 60. We've got the increase, and then we're going to do a prepared value of 90. And then we got the red. Okay, so that's the first way of doing things. We could have done that horizontally. We've done it vertically in this instance. So we've cheated slightly. Where I said we're going to do image manipulation, we haven't actually done image manipulation at this stage. This is just an easy way of doing a bar that rises up over the top of an image you've already got, and you would actually put this on top of the image that you have. As a way of seeing that we have images built inside TwinCat HMI, we've got this G Gallery Explorer. It opened up on my other screen, so let's just drag that across. We've got some industries inside here, or processing, that's probably the best thing. And we can actually open up and have a look inside some of these. I don't know, actually. I've not been delving in, but let's just have a look, see, just in case there was something that's cylinderish, or I won't spend too long on this one. So palletizer saws. No, we won't get too much. There we go. We've got some logos in there and some icons. No, I'm going to call it a day of that. Right. Okay. So yeah, you would have just dragged an image in underneath the surface of this. Next one. So that's a simple way of doing things. If we're going to take this into the slightly more complex now, so let's say we wanted to manipulate an image, but the image is an image and it's a complex image. Quite often in this instance, we would use something like a scalable vector graphic. Now, scalable vector graphics are themselves a markup language. It's HTML. It's HTML. It's XML is inside a scalable vector graphic, and because of that, HTML has the ability to take them inside, and you can see inside a scalable vector graphic. And not only that, we have the ability in JavaScript to manipulate it. So, so in this instance here, what I'm going to do is I've already got a scalable vector graphic prepared, and I'm going to bring it in so it's part of our project. And for this, I'm just going to bring in a HTML host, so that allows me to add my own HTML into TwinCat HMI. Swap onto code view, and you can see it's got it highlighted down here. So this is going to be the space that I'm writing. And I'm just going to paste in my SVG. Now, I will take you through where I got this from and how I created this afterwards. But let me just start with this part of the project first. So this graphic here, if we swap back, is a can, just a form of fuel can that I'm going to use as this example. And it shouldn't resize. There we go. So there we go. So we've got our fuel can that we can use. In order to change the height of how much it's filled, it's this gradient transform. So if we just look inside here, so it's currently set at, oops, let me just open this up, 260. If I set this to, let's say 100, can save this and then swap back again. Let's just make sure it does go live. Okay, it's not actually doing it on this one here. It probably will on a refresh. Reload. Yeah, there we go. Okay, so so what you can see here is this scalable vector graphic. I've modified it. I actually took it into a different package, which I will show you afterwards. And what I'm doing is I'm saying this inner area, this area here, is really actually a closed shape. It's a shape made out of paths. And what I've said is I want to have a fill style, but the fill style is going to be a linear gradient. It's going to have almost no blending. I've actually compacted the blending up so that it goes from one to the other color instantaneously. And then all I'm doing is I'm cheating by saying, well, I'll move the point at which the gradient takes place, which now gives me this nice filling effect. Now, the nice thing with this, the thing that differs with what we've done over here to this one over here, is we can now follow this complex. We can follow the shape of this inner element. So if we step that up slightly further, let's just go back into our code and open up our scalable graphic again, which is just living down here, and our gradient transform. We're just going to go 50. Save that. Sorry, let's just swap back over and reload. Okay, so what you can see here, see it's following that path. It's actually filling this enclosed shape. So that's great. So now we truly are affecting an image. We're affecting the fill color of the inside of the image as well. So really the world is your oyster now. If you've got very complex vector shapes, you can individually highlight certain parts. We could change the color of the gradient as well, or we could change color of parts of the fill. Everything is possible. So this step, what we're going to do now is, here is the scalable vector graphic. This is just me manually dialing it in. How would we go about changing this value dynamically attached to a symbol? The best way of doing this is to do this in live view. You can live view code JavaScript, and then once you know what you need to write, you can then pack it into JavaScript inside TwinkHMI. So let me just start up live view. I'm actually going to use Microsoft Edge for this. So I'm just going to spin it into Microsoft Edge. That's just loaded on my other screen. I'm just going to drag it on. So Microsoft Edge, again, Microsoft Chrome is fine. I'm only not using Chrome because Chrome is my main web browser, and therefore it's covered in my shortcuts and things along those lines. So Edge is nice and clean. So what I would do with this is go into Inspect, into Console, and Console allows me to now live code JavaScript and influence this page. Now, things that we can find first. Let's just move this slightly down. The things that we will need to know if we're going to influence this is we're going to need to get access to this linear gradient, and it's ID'd. So we can use inbuilt JavaScript functionality to say, give me this ID. This is something we can ask. So if I go back to this one, if we're going to say, we can just prep it and we can say, I want to make a variable. The variable will be called grad for gradient. It's going to equal, and we'll do a document, which is a standard thing. So document means everything in a document object model, the DOM. I want to get element by ID, and the ID that I want to use is gradient1. Okay, and that's it. It executes the code, and it is actually holding a live copy of this running in Edge, in Chrome. It's actually based on Chromium. So what we could do now is now actually say, well, just show me grad. And if I enter that, it says, yeah, there is something in this variable now, and it is my linear gradient. So it's actually pulled that part of the DOM out. We can then do something along the lines of grad. So because I've now got that element, I'm actually holding it. We can do something like a set attribute. And if I open up the brackets, we have to put the name of the attribute first, followed by the value that we want to change it to. Now we can steal this out of here too. So anything that's blue on this line is an attribute. So gradient transform is the attribute we want to affect. So that will be put into here. And then we're going to change the value of it. So we're going to take the value out here and change that to, let's just say, we'll put that back to our 100 again, just to prove that that's okay. So as we hit enter, you can see it took effect. So we now, by using Microsoft Edge, we can now see that the code we have just written is correct. It did work. So now what we need to do is lift the code we've just written and put it into TwinkHMI. So there we go. Right, so I'm just going to grab this line up here to start with. Let's do a copy on there. I'm going to swap to this view. And again, because I'm going to say that the HTML host is going to look after this, because I can't actually select the SVG inside it, because SVG, that's just not possible. As far as TwinkHMI is concerned, it can only see up to the HTML host. So this is a good place to put your control logic. So, and where I'd expect to find it. So you can put it anywhere, but this is the best place to put it. So inside the HTML host, we're going to make an event. The event will be, we'll bind it to the other one, so we've got tank level 2 instead. So we're going to say whenever tank level 2 changes, do this event. Inside our event, we're going to do some JavaScript. And if we edit the source code, we're now going to copy in the code that we've just written from behind. Just save us some time, so we're going to take in the first line, step back, put that in, and then we're going to put in the second line, which is this one here. Okay, so the next bit, the slightly more complex part of this process is that we need to get access to the variable, the actual value of the variable, which we will then replace this 100 with. So in order to do that, we have to use the TwinkHMI framework, and we have to actually ask it to go off, get the PLC symbol. Now, the thing with that type of request is because it's going to use the network to do it, it's an asynchronous call. So anytime we do asynchronous calls in JavaScript, especially with our framework, we use what's called a callback function. So you can see this as saying, hey API, this is the symbol I'd like you to go and get. Can you please go and read it for me? And when you have finished reading it, whenever that is, because I don't know, here is the function I'd like you to run when you come back. So these are called callback functions. There are other methods that we can use in JavaScript. We've got things like async await, or we've got promises, but typically with the API that we use and the style of programming that Beckhoff uses, they just pass in callback functions. So just see it as a function that gets called later, because we don't know when this thing is going to complete. This isn't synchronous code. I can't say, read the symbol, do something, because it could take it a matter of seconds maybe to go. It won't. It'll take less than that. But let's say, for example, it was over a network, and maybe that network included the internet. Then yeah, you could have a couple of seconds wait while it waits for that to go do its thing and come back. Okay, right. So what we're going to do is swap on to our the API reference, which is on Infosys. So Infosys, we're going to go into TE2000 framework API reference and TCHMI. So TCHMI being our main namespace. This is where a lot of our functionality lives. Inside TCHMI, we're going to go for symbol. And then what we're doing is we're going to do a readx2. So readx2 is just a more slightly advanced version of our readx, and we get examples here. So let me just pull this example out, and then I'll speak about it line by line. So I'm just going to put this in here. So what we're saying is, can we... There we go. Right, so I'm going to say readx2, can you please go off and find this variable? And when you do, can you please execute this function? So we've actually defined a function in our method call. So we're saying, yeah, method call takes two parameters, the symbol that we want to read and a function. We're actually going to pass an entire function in as an argument to this method. So, and the function says, I have a function. I'm not calling the function anything, it's just an anonymous function, but it will have an argument called data. And then when that function runs, I can now evaluate data, and data.error will come back and say, do I have any errors with what we've just done? Otherwise, for the time being, it's going to console log out. It actually assigns the variable value to data.value, and then we console log out value. So we'll leave that bit of code in there to start with, just to see if it works. And also as well, we have error handling, so we can do else. If there was an error, we can handle it in a certain way. Maybe we want our control just to wait or do nothing, or to report an error via console log. That's entirely up to you. So I'm just going to remove that one for the time being because we don't need it. We'll take out that comment there as well, just to tidy up the code. And the most important thing we have to do here is swap this value with the symbol that we want to read. So if I just OK that, and what I'm going to say is write to symbol. This is a quick way of finding what expression name we need to use. So create data binding, tank level 2, and what we can actually do is click it and say copy. And now when I go into here and paste, it pastes that expression. So that's a very quick way of doing that. Okay, we'll leave this as is because that's not going to affect us too much. It's just going to put 100 into our gradient every time that we get an updated symbol. But this is the first thing that we want to try here, this console logging. So we will OK that. We will remove this extra line that we don't need and say OK. And this was on tank 2 changing. So we can just save this. It is actually already working behind the scenes, so let's just swap back to our live view here. I'm just going to refresh it just so we get a nice clear log. And we have got 3 turn up. Let's just see if that is correct. So let's go into main, log in. Here we go, we have the value of 3 in there. Okay, so prepared value, we're going to put in 22. Sort back, and we've got the value of 22 come out. So that shows that this is working. So we've got working code, we've got asynchronous code working. It does a callback function, takes the value, and then it gives it to us in data.value. So it's now up to us what we would like to do with that. Something you didn't see behind the scenes, I did actually stop the video. I know I say that I do live coding, and if there's any errors, I correct them while we're there. It was a long error this time, and there was a certain amount, only a certain amount of digging that you'd want to watch me doing. But what I can do is expose what actually occurred. Because it's definitely something that you may experience. What there was is when I went back into this control and looked at the events weren't actually there anymore. So anytime I created an event, they disappeared. Now the problem is my original SVG code had an error with it. And let me just shut down live view and just show you what the error was. If I just open up the screen so we can see both. Just here, I had the end of a title tag. I actually had the closing braces of a title tag, which meant I had corrupt XML. It wasn't a true HTML document, and therefore Twinkle HMI itself wasn't able to parse it correctly, and therefore any of the events that occurred after this, and it actually lists the events out just down here, by that point the parsing had already failed because it said that it didn't understand what the markup document was above. So so this was actually causing this to be hidden. Every time I made one, it disappeared. And so a quick check, and lo and behold, when I was making the SVG, I've actually left a closing brace in there. So yeah, there we go. I've just cut out probably 15 minutes of a video where you just saw me just remaking the project from scratch and getting back into there. But there we go, passing you over. This is truly live coding. So I'll just edit it so you don't see too much waffle from my side. There we go. So that's that side of fault finding that we could see. Let's just swap that back. Let's just swap that in. I'm just going to move this out of the way as well, just to tidy this back up again. If I can, there we go. Just pull that off to the side. Disappear code. Okay. Right. So we're happy that inside this event we're pulling the correct value from the PLC. So now what we're going to say is I'm going to lift all of this code up. And I'm going to put this, let's just cut that out, and I'm going to put it into the callback function. So this code here is now going to get called in the callback function. So when this function here fires, it will now have the right value of data.value because it's asynchronous. It's gone away, come back, and called the function once it's come back. And now we can say, go grab the gradient and then set the attribute. What we can do, because this thing here is a string, we can just do basic string concatenation in JavaScript, which allows us just to use the pluses. And also as well, because we're getting a integer value back, the minute you try to concat a string with an integer, it auto converts it into a string. So there's not too many things we need to do here. We can actually just pass value straight into this area, and it will turn it into a string for us. If, for example, if this was a long rel that we were passing in, we would have to do some form of toFixed, and then I'd probably go one extra stage and say the toFixed, I want it to do it toString, or yeah, make it into a string just to be safe. But again, feel free to add whatever protection you need over your values. We will remove that as well. Just cut this down to exactly the code that we needed. So there we go. We could have actually used data.value just straight in here, but we'll assign it to a value first, and we'll OK that. I haven't done any scaling. I'll leave the scaling up to you, because as you saw here, just the way with this scalable vector graphic works, the gradient actually worked with, if I have 0 in it, it's actually full. And when I start adding values to it, it starts making its way down to a value of around about 280. Now that corresponds to how big the scalable vector graphics is at its core, not as I've drawn it here, but when the graphic was created, that number is fundamental to it. So you would have to do some scaling. Now you can either do some scaling inside here, or you can do scaling in the PLC. So wherever you feel it's right. In this instance, I'm going to do the scaling in the PLC, so I can just drive the values. The important part of this demonstration was how to get the values across. So if I just go into main on here, and we're going to change this value into 100, which is the value that we know. You can see it's now gone down. And we'll go into something like 200, and we'll go up to a value of 50. There we go. Successful. There we go. That's a fair amount of code there. Obviously, we've been speaking for quite a while, but this shows you two different ways of doing it. We can either go the simple route and just grow a rectangle over the top of an image that already exists. You could, if the image itself had transparent parts, you could actually put the rectangle behind it as well, and then put your image above and just see through the transparent parts. Transparency is mainly supported by pins, so you need to use a PNG file. Bitmaps don't support transparency, so you can't use any of that. A JPEG, from what I understand of JPEGs, you can't use transparencies in JPEGs either. So a ping is the way you'd want to go. Either putting the rectangle in front or a rectangle behind. You could have quite a complex shape that fills up behind that, but obviously that's entirely up to you. The second method I've shown you here is by bringing in a scalable vector graphic, how we can actually affect its markup using reading symbols, and then on symbol changes we can then go in and actually play with the XML that's behind the scenes, the HTML that's behind the scenes. Okay, so that's going to be really the official end of this video. Now feel free to just stay for a slight bit longer just to see how I made the scalable vector graphic. So yeah, it just shows some of the tools I used and the process I took. So if you're still with us, well done. This is a long video, and hopefully it's not going to get too much longer. The first thing I do is I use a site called, there we go, it's just going to dock it into here, Icon Finder. So Icon Finder, you pay or you can have free icons. Shout out to Icon Finder, they're really good. I've used them a lot of times just for doing demo things. And yep, feel free to be a premium user of this and just get your icons from here. If we select, you can see the fuel count I've used for this example, and they give you the option of saying that I want the SVG version of this, and then you download the SVG. Let's just run a download again. You see it come down here, and I'm just going to say I won't show it in folder just at the moment, just in case I've got anything else in my folder. But if we were to open that, you would then see the scalable vector graphic as we saw it here. It breaks it down. Let me just move back onto this. So back into desktop view and go into code view. So opening it into an editor. So let's just swap that over. I don't think it's swapping over because it thinks I've still got this open on the side. So you'll actually see it breaking itself up into these things here, which is paths and the colors. This is just a defined way of doing scalable vector graphics. The thing it didn't do, on the other hand, is it didn't have an inside gradient. So what I did is I then used a online tool, let's just drop that into here as well, called Vecteezy. It's a free SVG editor. I imported SVG, so I just pulled it straight back in again. I then took the shape and I found some of the boundings. Now, originally, this shape here, it had the curve of the handle was all part of this back bit, which the problem with that is if I then did a fill, it filled all this handle space here. So what I did is you can double click, oops, let's just come out of that. When you double click on this, it allows you to now play you can see you can play with the lines themselves. So what I did is I actually forced the lines to go down and follow the original shape. And then I went in and inside this one here, oops, let's just go back onto my select tool. I then had to remake a handle. So I actually built this handle from scratch, which was just using their pen tool. Drew this line through, and as you can see here on the pen tool, it's a case of selecting different lines. And as you drag and pull, you can do curves. It's standard vector drawing in essence. Once that was done, and I was happy that I could fill my shape, I was also doing here a fill setting of linear. And as soon as I did, it allowed me to draw on this linear gradient. Once that was complete, I was able to do download SVG. Sorry, downloaded the SVG again, and it gives me a compacted up SVG. And then what I did after that is, just to make this a little bit easier to read, is just by typing in XML pretty, it gave me a XML formatter inside Bing. It decided to use, because I'm using Edge at the moment. So this in here was actually the scalable vector graphics. Now they pad it with this XML tag just at the start. Now that's because the file is normally running in isolation; it just runs on its own. Because we're going to embed it inside HTML, I actually dragged out the SVG from this point here up to the closing SVG tag. So that's the part you need to pull out and drop into your Twincat HMI project. And the last thing, looking inside, and again, just by doing a small amount of Googling, I was able to see just at the top here that we have these linear gradients, so I could tell where it made the linear gradient. And also as well, because my mouse clicking wasn't particularly accurate, it had set up gradients for me which had quite a hefty amount of decimal places. So again, with some Googling, I realised that I can actually tidy up. Let's just move this out of the way. I could tidy up the transform of my linear gradient. So if we just pull that over here, so that gradient transform, all of those decimal places could actually tidy up into 1001, 050 being how high it was. I believe the 1001 is what allows me to rotate a gradient from being vertical to horizontal, but any of you who know matrix transformations, you will be fine with this. So, but otherwise there's plenty of Googling out there. But actually drawing it in that package already put this thing in the right orientation for me anyway, so I just had to go in and tidy some values up. Then the other thing that I can see here is it allowed me to spot, and hopefully I can find it quickly, was where we actually tie the filling of the area with this gradient 1. Actually, if I highlight it, it should allow me to let's just find that. So just find the next version of it. Gradient 1, which is there. It's on the end of this long line here. So that long line here is actually this very first path, and that path is the bounding of our can, and it's saying the fill style of it, please use the ID of gradient 1, and therefore gradient 1 is then defined up in this linear gradient. So yeah, that pretty much completes it. So if I wanted to change the color of it, I could go in and pull out the stop color, start color. So maybe as it's filling up, not only am I filling it up using the linear gradient, I could actually start changing the colors of my linear gradient as it starts making it up. For example, was our first example where we made it turn red when it was getting to a dangerous level. Okay, I'll call it a day now because that was a very long video, but hopefully that gives you some good ideas that you can use in the future. Okay, thank you very much.